recording. Yeah. All right, guys. So this is our next lesson here. We're actually getting close to wrapping up Unit 2A. So this is kind of the last bit in polynomial functions. So remember, polynomial functions are just situations like this where we have multiple terms, multiple, monomial, or polynomial. Nomial is talking about each term. So we have multiple terms here. So we're going to be given, some fancy polynomials to look at, and just from the polynomial expression, we're going to be able to tell what's going on with the graph without graphing it. Now, we aren't even going to go to the step yet where we are going to graph it fully. We're going to find all the information around it, and that's going to give us a good idea about what the graph looks like. Okay, so we have a couple parts that we just have to label here. The parts are the n value is the degree of the polynomial. So how did I know that the n value was 3 for this polynomial expression? How did I know? You can even unmute. How did I know that it was n is 3? What do you think? Anybody?
Because it's the highest exponent.
Highest exponent. Look. The highest exponent is always the first term, so we just have to look to the first term. Good job, Alicia. So 3 is the highest exponent, so I know that the n value is 3 for this expression. Next, somebody tell me, what would the leading coefficient be? What's our a value, our leading coefficient in the same situation? It's not as obvious as what I put. So what do you think? You can probably show me on your fingers. What is the leading coefficient of that expression? What do you think? Leading. Coefficients go in front of the variable. Good. I see twos. I see twos like this, with barely like off in the corner. 2. It's 2 because the leading coefficient, here's the leading coefficient of the first term. So 2 is our a value. Pretty easy to find a and n. A and n are pretty quick. Look in the first term, look at the exponent, look at the coefficient. Boom, boom. All right. Now to find how many turning points, so a turning point is literally when the function turns going the other direction. So this has 2 turning points. 2 turning points. Okay? 2 turning points. So the turning points we would find by first looking to see, well, what was my n value? What was my n value? For this case, it was 3. And to find the turning points, you're going to do the n value minus 1. So 3 minus 1, we'd have a maximum of 2 turning points for this equation here. Okay? So it's just like, hey, find your n, find your a. The rest of it are going to be pretty straightforward. The n behavior is a little bit tricky, but it's having to do with n, has to do with a. You see down here, we're looking at n, we're looking at a, n a. Here there is an n. Anywhere you see an n, you already have figured out that information. Well, you just have to go in and know what it's talking about. Okay, so the main 2 things, the letters that we use are n and a. Turning points are relative minimums and maximums. You may have learned that in math too. You may not have, and it doesn't matter to me. I'm going to teach you. I'm going to remind you. All right, so look, this is a relative minimum. This is, right here, this point is a relative maximum. Okay, in the chat or unmute, let me know, why would those be relative minimums and maximums? Why are those relative minimums and maximums? Because looking here, the function keeps going down. So this isn't the ultimate, this isn't the minimum. This is the relative minimum. Why is it the relative minimum? And why is this the relative maximum? It's like a roller coaster. The reason why this is the relative minimum is it is the minimum along the function. It's the minimum as far as when it turns. This is the bottom of the roller coaster, the relative minimum. This is after you go, up the track. The relative maximum is when you're at the top of the roller coaster. Okay, that's all it's saying. And the track may go all over the place, but if I was saying, hey, what's the relative min and max between 1 and 3? You'd be able to see, okay, it's the bottom, it's the lowest one and the highest one there. So turning points are also the relative minimum and maximum. Our roots are the number of x-intercepts. So if this was my coordinate grid, right, I would have roots right here, and right here. Those are our roots. So the roots, the number of roots has to do with our in value. It's equal to the in value. So we know that these roots for this function would have, since its in is 3, we'd have 3 roots. There'd be 3 places where it crosses the x-axis. Okay, those are our roots. All right. Hey, it's like a map. Again, all we're dealing with polynomial functions. We're dealing with them as maps. And thumbs up, sideways down for finding and looking for those really 2 elements, turning point and roots. Pretty good. Can we find them? You're not sure yet? Okay. You're waiting for it. You're like, when is it? You're waiting for it. This is the last thing we have to find, our in behavior, and then we will know what this graph basically looks like. We're not going to find the actual roots, but we're going to know that it crosses the x-axis, 2, 3, 4, 5, 10 times. So if n is even and a is positive, then this function is going to, it might go up and down, but it's definitely going to, our in behavior, what's happening at the ends, right? Our in behavior is up to the left, up to the right. So based on what the in and the a value are, it also tells us how this function is going to either go up both ways. It's going to be like a sad face going both down. It's going to go down and up or down and up. Okay. So it's a matter of knowing this is like a map. Okay. So if n is even, a is positive, it's going to go up on both sides. I don't know what happens in the middle. In behavior is just, I just want to know what's happening at the end of this function. All right. So the in behavior for this one, if n is even, and a is negative. I don't expect you to memorize all these things. It's a map, so you're going to be given the map, but you got to know where and how to use it. If n is even, a is negative, then we both in behaviors are going down. So it might look like, instead of the other one, it might look like that, right? Both are going down. Next we have, if n is odd, a is positive. On the left side, left and right, left side's going down, right side's going up. One year I had a kid make a dance out of this. It involved the kind of wave with the arms. You don't have to do that. That was special. If n is odd, a is negative, it goes up on the left, goes down on the right. Okay? So this one might look like this. Right? This one might look like that. All right? So we're just looking at what the shape looks like. So let's look down here at this example. And I don't think you had this written down, so I'll give you a moment to write this down. Okay, another couple moments. If you don't get to find all these things out, you can do them as we go through one at a time. All right. Let's start by finding our 2 main indicators, in and a. So tell me in the chat. Give me in, comma, and then give me a. Give me in, comma, give me a in the chat, please. Let's see it. Very good, good. All right, Josh, perfect. Alicia, perfect. Anyone else? Yeah, Ziamara, perfect. All right. N is 5. A is 6. Yeah. And how we knew that? We know that our N value is our power, and our leading coefficient is our A value. So you just have to look in the first term and just pull that information out. Now, turning points are going to be, let's see, N minus 1. So guess how many turning points? Go to N, it's 5. So number of turning points is going to be 4 maximum. 4 maximum. It's not always to the max. It might turn once or twice or 3 times, but the fourth 4 is the maximum. Number of roots is equal to N. There's going to be 5 X-intercepts. That's our roots, remember. And then I'll pull down the N behavior here. Let's see. So let me know in the chat, is this going to be up, up, a down, down, a down, up, or an up, down? Up, up, down, 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 up, down. What do you think? What kind of behavior? Alicia, Sonia, Santana, good, good. Anyone else? Joshua, perfect. Not up, up. Not up, up. Double check it if you said up, up. Everything is paused. Okay, everything froze for me for a second. Weird. All right, so let's look. Down, up. Perfect. Good job. Good job. Look, N is odd. A is positive. Those are the main things we're looking at. Is it odd or even? Is it positive or negative? So then I just have to use my map and look here. N is odd. A is positive. So we're going to end up with, it's going to go down, left, up, right. Okay. Now, it isn't too much further to actually graph them. You're not going to have to graph them for the homework. Okay. But if I was looking at this, one thing I know, I could also find my Y-intercept. So I want you to add that here. When we do get to graph it, we're going to find our Y-intercept, because that's when x is equal to 0, the Y-intercept is going to be what's left over. And this isn't hard to do. That's why I wanted to do this extra one. Watch. Plug in a 0 here. What happens to this term? Gone. Plug in a 0 here. What happens to the term? See ya. Plug in a 0 here. You're out. Okay? So what's left over when we plug in 0 for x? 7. So if I wanted to make a super rough sketch of this, here's what I know. I know that it crosses the y-axis at 1, 2, 3, 4, 5, 6, 7. All right. I know that it's going to go down, then up. Nope. Down, then up. I know that we have, let's see, 4 roots. No, 5 roots. So it's going to cross the x-axis. Whoops, that's not right. It's going to cross it 5 times, right? Let's see. Turning points, we have 4, and that's all we had. So let's look. If I have 5 roots, 4 turning points, I'm going to make it like this. I'm going to go here, here, up, down, up. All right. And this isn't exactly what it looks like. We'd have to find our roots to find where it crosses. We'd have to find these inflection points, which actually use calculus to find those. So you won't be graphing these unless you in college, go into calculus. Now, look, how many roots do we have? 1, 2, 3, 4, 5. That works because we knew we had 5 x-intercepts, 5 roots. How many turning points? 1, 2, 3, 4. 4 turning points. Let's see. In behavior, down, left, up, right. So it's a good guess. It wouldn't be exactly right, but you could see that, you could, if I gave you 5 graphs and I said, hey, figure out which one matches with this equation, you would be able to see which one, has this many roots, this many turning points. So let me pause for a second.